Hey, so this is the first video notes. The first chapter is going to be going over basic algebra stuff, and then we'll get into some linear equations stuff after that. But for today, we're going to talk about variables, expressions, and the order of operations. So, first thing on your notes worksheet, why letters in math? A variable is a symbol used to represent a quantity. So that's your letter that's in the math, like X or whatever. It's called a variable. And the reason that we have them is, first, using a letter to represent an unknown quantity, and what we know about that quantity can help us figure out what the number is. So if you don't know what the number is, you can write an equation that has a letter to represent it and then figure out what it equals. Second thing is, sometimes we can use variables to represent numbers that might take different values at different times. So on your notes worksheet, there's an example space under each of those. That's going to be these two things right here. So this will be underneath that on your notes. This and this will go underneath this on your notes. So the number of dogs is 1 more than 3 times the number of cats. There are 19 dogs. So at this point, you don't know the number of cats. But if you write out what you do know in equation form, just using a D for dogs and C for cats, and then you can just put that number in for D, then you can solve it for C. And now you know what C is. It's the number of cats is 6. Okay, the other one where it could represent different values at different times, that's these two. So Celsius, if you want to find out what the temperature is in Celsius, and you have it in Fahrenheit, you just plug in the temperature in there and what it is in Fahrenheit and get Celsius. Or this one, you can plug in the Celsius and get the temperature in Fahrenheit. And that's true for lots of different, for any temperature that's possible. Okay, next question on your notes. Why do we use the letters we do? Some people say, why do we use X, or why do we use this? It doesn't make any sense. Well, basically, you get it. Y and U are letters. You just pick a letter. Doesn't matter. Whatever you want to use, pretty much most of the time. But is using the first letter of something's name can help it make more sense. So, like the last thing I wrote, D for dogs. So D in an equation could represent, for instance, the number of dogs in the park, and it makes sense because dog starts with D. Alright, another thing for why you pick the letter you do, X is often used for continuous quantities, and N is often used for discrete quantities. So discrete is like 0, 1, 2, 3 integers, okay? Continuous could be a decimal or a fraction. It could be any number. It could be 3.169. But N, it would either be 2 or 3 or 7 or whatever. So that's not always like that, but that's why sometimes you are more likely to use X and sometimes you're more likely to use N. Okay. What do you need to remember if you're getting confused on something or just having a hard time with an equation? Ask yourself, what does this represent? So this equation right here, when you first start looking at it, say to yourself in your mind, okay, D is the number of dogs and C is the number of cats. And that can help you think, what am I actually doing here? And then you start solving it, subtract 1 from each side, then you can, if you're starting to get confused, think, okay, D minus 1 is the number of dogs minus 1. 3C is 3 times however many cats there are. So if there's 6 cats, 3C is 18. If there's 10 cats, 3C would be 30. So think like that, and it will help you get unconfused, hopefully. Okay, expressions. An expression is a thing that expresses mathematical operations. That might sound a little confusing, but here's a couple examples. 3 times 4 plus 4. It's got operations. That's adding, subtracting, multiplying, dividing. If it's got that stuff in it, it's probably an expression. So 3 times 4 plus 4. It's got multiplying, it's got adding, so that means it's an expression. 4 times 4, it's got multiplying, so it's an expression. Okay, and the activity we did last in class, the results we came up with were algebraic expressions. If it has a variable like an x or an n or whatever in it, that means it's an algebraic expression. So if you have two expressions that are equal to each other, then you can call them equivalent expressions. And you can write them side by side and put an equal sign in between it, and you've got an equation. So an equation is saying that two expressions are equal to each other. So hopefully that helps with remembering what an expression is. So a couple examples from that activity. I'm going to cover up part of this as we go. So these are two different answers that you could have gotten from that activity. And they're both representing the same thing, right? The number of dots, which is the same in either case. So if they're both correct, they should be equal to each other, right? If they're both representing the number of dots in the same square, the square with n dots on each side, then this and this should be equal. And to check that, you multiply 4 times n, 4 times negative 2, and 4 times n, 4 times negative 1, and simplify it. Negative 8 plus 4 is negative 4. Oh, they're equal, just like we expected. This other one is a little more complicated, the n squared minus n minus 2 squared. Okay, so the n minus 2 squared means times itself. So n minus 2 times n minus 2. And just looking at that part for a second, n times n is n squared. N times minus 2 is minus 2n. Minus 2n plus 4. And keep simplifying. And we get 4n minus 4 equals 4n minus 4. We're good. So any two answers that were correct from that activity should be equivalent to each other, and so you can make an equation out of them. Okay, so now to order of operations. Why do we follow this deal here? First parentheses, then exponents, then multiplying or dividing, then adding or subtracting. Well, it's just something somebody made up, okay? There's nothing that naturally requires the order of operations that we use, okay? It's a standard convention. That means people just decided this is the way we're going to do it so that everybody does it the same way and we don't get confused by different people doing it different ways. It's like in the United States, people always drive on the right-hand side of the road. It's a standard convention. So it's not a natural part of mathematics, it's just a convention. But it's still important. So why have it at all? So we don't have to write a whole bunch of parentheses every time, okay? So think of this example. 3 times the number of cats plus 5 times the number of dogs. Is that 3 times C plus 5 times D? Or is it kind of like if you put a parentheses here 3 times the number of cats plus 5, then times the number of dogs? Or is it 3 times the number of cats plus 5 times the number of dogs? Or is it 3 times the number of cats plus 5 times the number of dogs? So we just have to have standard rules so that everybody does it the same way and that we don't get mixed up. So if you see this, you know that you're not supposed to add the c plus 5 first, because that's the standard way that everyone does it, is multiply those first. And if we wanted to say add the c plus 5 before you do the other things, we'd put a parentheses to note it. So if we didn't have this, we'd have to put parentheses on every single piece like this. Okay, and that would be just a whole bunch of extra writing. Okay, vocabulary. Terms are parts of an expression that are added together. Factors are parts of an expression that are multiplied together. Okay, example of terms, 5d plus 3c. The two parts that are being added together are the terms. So the 5d is the first term, the 3c is the second term. The result of adding the terms together is called the sum. For factors, like say you have x times y, x is a factor and y is a factor. Or if you have 5 times 6, 5 is a factor, 6 is a factor. And the result is called the product when you're multiplying. Okay, I'll finish up with a couple examples here. So this one right here, 3x plus 2y plus z cubed. The 2y plus z cubed in parentheses. And it tells you x is 4, y is 5, and z is 3. So the first step, plug in those values. X is 4, y is 5, z is 3. So next, 3 times 4 is 12. You can't do anything to combine that with this stuff until you deal with the inside of the parentheses, though. So 2 times 5 is 10. 3 cubed is 3 times 3 times 3, which 3 times 3 is 9, times 3 is 27. And then adding those gives you 37, adding that gives you 49. Okay, this example right here, zoom in a little for you. So 8 plus 3 cubed divided by 12 minus 7. So you need to look at the top and the bottom separately to start with. So on the top, the 3 cubed again is 3 times 3 times 3, which will become 27. 12 minus 7 gives you 5 on the bottom. The 8 plus 27 gives you 35. Now you can divide, and 35 divided by 5 is 7. Alright, that's it. Thanks for watching. Make sure you bring your notes sheet to class.